Hi friends, welcome to my short-term course on basic electronics. So let me introduce myself first. Myself, Amrinder Kumar, an electrical engineering student at SV Set Chip 2. So let me introduce about our courses. Our courses is on basic electronics. So we'll discuss here some basic electronics components as well as basic electronic circuits. So now our topic is half wave rectifier, full wave rectifier circuit. So first we will see half wave rectifier one by one. Then we will see after full wave rectifier. So let's see rectifier. So this is crystal diode rectifier. So we need to know about diode. Diode is also a basic electronics component or device. You can say that. So first let me introduce something about diode. Diode is a two-terminal electronics device which made from silicon, right? That the main property of diode is it allows the current in a single direction. Okay, so that's what we are using diode here in rectifier circuit. So let's come to the rectifier circuit. Actually, what is rectifier circuit? Rectifier circuit is that circuit which converts AC to DC signal, right? Pure DC voltage, or we can say that. The following two types of rectifier circuit can be used. One is half wave rectifier, another is full wave rectifier. So let me give you one live example of rectifier circuit. See one live example. In our day-to-day life, all mobile chargers and laptop chargers are the best example of rectifier circuit, right? So rectifier circuit do like that. Whatever AC signal is there, it converts into DC signal because our mobile and laptop and many more electronics device working on DC voltage only. They no need to AC because in electronics gadgets we are using diodes, amplifier and all are working on pure DC voltage, right? So we need to convert this AC to DC because in our home and everywhere we have AC supply, so we need to convert into DC. So most important thing is rectifier circuit. So we'll discuss these things also, how the mobile charger is working and how it's making like a mobile charger. We'll discuss more things later about mobile chargers. So let me introduce first here about half wave rectifier. So next slide, come to next. Okay, sorry. So half wave rectifier, right? The process of removing one half of the signal to establish the DC level is called half wave rectification. Removing one half of the signal. So as you know that in AC signal we have two half. I mean one half is positive and another half is here. One half is positive and another half is negative, right? So in AC signal, in each cycle we have positive half as well as negative, right? So the line is saying like that the process of moving one half of the signal to establish the DC level is called half wave rectification, right? So see here in this example, suppose rectifier circuit like that. This is 230 volt AC supply with 50 hertz frequency. This is a step down transformer. It's a step down voltage from 230 to 9 or 12 volt AC only. So here this is one diode we are using in half wave rectifier, right? So in positive half cycle, this one positive half cycle, the diode D1 is conducting. I mean this is in forward bias, conducting and current flowing through this like this. So positive half cycle, there is the same thing here. But in negative half cycle, this diode is in reverse bias, so it blocks the current. So in negative half cycle we have zero current. Again in positive half cycle we have current same as input. while in negative again we have zero current. So come to next slide. Half wave rectifier, as you know that AC voltage across secondary terminal AB changes its polarity after each half cycle, right? Each half cycle it changes. First half cycle is positive, in another half cycle is negative. During negative half cycle, terminal A is negative, this one, as diode got reverse bias and conducts no current. So during negative half cycle, point this one A is negative here, so this one is reverse bias, then no current in here. Now, so current flows through diode during positive half cycle, right? In this way, current flows through the load RL in one direction only. Yes, of course, it's one direction because here input we are supplying two directional current, positive as well as negative. But at load side, we are getting single direction current here. See, single direction current, right? So come next slide. Now we see half wave rectifier and disadvantage of half wave rectifier. The pulsating current in output contains AC component whose frequency is equal to supply frequency, so filtering is needed. Yes, of course, filtering is needed because pulsating current in output contains AC components whose frequency is equal to the frequency of input. I mean, the frequency of output, rectified output, is equal to the frequency of uh, AC input. So we need pure DC. So in order to remove the frequency, or you can say ripple factor from the rectified output, we need a filter such as capacitor filter or inductor filter. Okay, so we will discuss filter later. The AC supply delivers power during half cycle only, so output is low. Obviously output is low because in negative half cycle there is no current. So obviously input side has more voltage, but output we get less voltage due to its negative half cycle has no current here, right? So now let me give you some time for think about this, about half wave rectifier. If you have any doubt, come to the forum and we'll discuss about this. So next lecture we'll discuss about full wave rectifier. Okay, thank you.